Oh.
Clothing styles.
Beard.
Beard. Jewelry styles.
Beards.
Music.
Beards.
Dance. Remember, evolution happens over generations. Food. Technology.
Shoes.
Should we go watch an example?
Tractor.
Example of evolution.
Ladies and gentlemen, now present them to you the evolution of hip hop dance.
That was Smith.
Yeah, that's Will Smith.
Terry Frank. That's Kiki.
Y'all go home and ask your parents about these dances.
Oh, we already know about this.
The walk. Y'all knew that.
Do y'all understand evolution now?
That was it?
Let's watch something else for
Alright, you got notes, and I promise you I'll tell you another one.
You pinky promise, Miss Bird.
It's gonna be on page 108.
Miss Bird, pinky promise.
Yeah, I promise.
No, you're not my Miss Bird.
Page 108. Now we're going to talk about evidence for evolution. So how scientists know evolution occurred. Page number is right here, 108. I know I have the table of contents. I have it.
And what page you got on there?
2 pages.
Miss Bird, what page is that on?
109.
Oh, you guys stupid and dead up here.
Oh.
I did not call her that. I was talking to her and then I said that. To her.
Page 108.
Y'all need to stop fighting.
Michael, you got it?
I got it.
Brianna?
That was snitching in this week.
Alright, so evidence, so we got 4 main types of evidence for evolution. You have biochemical evidence, anatomical evidence, fossils, and embryonic structures. So the test and EOC, those are the 4 main types of evidence for evolution. So the biochemical, anatomical, fossils, and embryonic structures. And they are all four on the test. And their vocabulary words. So make sure, I'll show you the definitions as we go through. But y'all, since I'm giving it to you today, it won't be on your quiz tomorrow. It'll be on the quiz when we come back. For Friday, we come back from break.
What?
Alright, so our first type of evidence is biochemical evidence. We're just going to go through and talk about all four. So our first type of evidence is biochemical. So biochemical evidence, three examples: DNA, chromosomes, and proteins. So if two organisms have similar DNA, what would that tell? Brett, put it up. Similar strands of DNA. What would that show? It would show that they may have a common ancestor, right? Or they may have a similar number of chromosomes. How many chromosomes do humans have?
46.
46. How many pairs?
23.
23.
You know.
And then last, identical or similar proteins. So y'all at the bottom right here in purple, I went through the exam, through the test, that will be on December the 5th. And I pulled examples that are on the test. So you don't have to write what's in purple, but if I were you, I would, because these are the test questions. I went through the test and pulled them. So y'all, the example biochemical evidence on the test, so it says if human insulin is more similar to chimpanzee insulin than to mouse insulin, what type of evidence would that be? And what's insulin? Insulin's a type of
Bacteria.
what is insulin? A type of protein. So what type of evidence would insulin be? Similarities in insulin be an example of what type of evidence? Biochemical evidence. Biochemical evidence. So y'all, when you're doing your note cards, definition, just put similar DNA, comma, chromosomes, comma, proteins. Okay? I tried to bold it. I don't know if you can see. And then for your picture, what could you draw for biochemical evidence? Two strands of DNA. Yep. Two strands. So our next type of evidence is anatomical. Anatomical evidence. Here, I'm gonna give you the next. So anatomical evidence, you got two types. We have homologous structures. What does the prefix homo mean?
Same.
Same. So what would homologous structures mean? So the same structure. So definition, this is a vocab word. Definition is structures that are derived from the same tissue. That means they come from the same tissue, but organisms use them differently. How we use an arm, is that the same way or which uses its leg? No, but they look, if you would look at the bone structure, they're very, very similar. And y'all remember to be smart in this. Y'all remember on the benchmark exam, they had a picture of these? Y'all remember that?
Yep. Because it was like, how did they relate or something, or did they relate or something like that?
So y'all, I'm like 90% sure, might be on the ESC, okay? A picture. And what would your answer be? Homologous structure. You come from the same tissue or different tissue?
Same.
What does home mean? Same. So on the test, it might say, two anatomical structures in different species produce the same tissues. Like the arm of a human, the leg of a cat. This would be an example of homologous structures. Just remember, homo, same tissues. So for your note cards, if you're doing pictures, you could just draw like two of these. You don't have to draw all five. Y'all, I haven't had anybody but older students, like Miss Millie's class and Miss Horton, they just print all their pictures off. Take them on their note card. So it'll be fine. You don't have to. Alright, so after homologous structures, so we're still under anatomical evidence, we also have vestigial structures. Vestigial structures is also a vocabulary word. So vestigial structures are structures that may have once had a function, but they have evolved and they no longer have a purpose or they're useless. So what's the famous example we talked about yesterday? An appendix, right? Your appendix is a vestigial structure. It has no purpose. It's useless. It may have once had a purpose, but has evolved, no longer has a purpose. Our wisdom teeth. What's the purpose of having wisdom teeth? Right. They have once had a function. They have evolved and they're now useless. And whales, are whales mammals or a type of fish?
Mammals.
A mammal. So whales actually have a hip bone. But do whales have hips?
Nope.
No. So what's the purpose of them having a hip bone?
None.
None. So y'all, anytime you see one of these three examples, you know we're talking about vestigial structures. And that just shows evolution. It shows they may have once had a function, they've evolved, and they're now useless. What did I say about wisdom teeth? Does everybody have wisdom teeth? Get wisdom teeth? No, so what are they evolving?
You're trying to get away.
Right. Alright, so that's all for anatomical evidence. Our next type of evidence is fossils. Everybody knows what a fossil is, right? Okay, so fossils, scientists can use those to compare bone structures, huh? We're still on it. You can use it back. So fossils, we can compare bone structures, and an important part of fossils is we can determine where an organism lived and when it lived. So you can actually use fossils to date. Determine how old an organism is. And then you can take that information and determine what organism lived with other organisms. So, I should have put this in purple. This is what I got from your test. So fossils can be ordered in a certain way so that scientists can better understand which animals lived before others, after others, or with others. So that's an important part of fossils.
Why is that possible? Answer.
Y'all remember in earth science, remember you can look at the layers of rocks and determine age?
Yeah.
Y'all remember that? A little bit?
Yep.
Yeah. So that's what they do. When they take a fossil, they look at the rocks, how deep it was in the earth,